All right, so here is Quideo number 2, the basic question. So the basic question says, the number of people living on American farms has declined steadily during this century. And it gives the data of the farm population in millions of people from 1935 to 1980. And the first question says to make a scatter plot of the data and then find the least squares regression line of the farm population. So first, I'm going to do the scatter plot on a calculator, but just to keep in mind, the x-axis are the years, and the y-axis is the population in millions. So on the calculator, it's probably the easiest way to make the scatter plot. So you go to Stat, Edit, and your L1 is going to be your x values, which are your years. And then the L2 will be your Y values, which is your population for each of those years. And then you go to second stat plot and make sure the first stat plot's on. You have the scatter plot highlighted and your X list is L1, Y list is L2. Then you go to zoom stat or zoom 9 and it shows your scatter plot right there. And you can see that it's declining. So the second part of the first question says to find the least squares regression line. So to do that, you would look at that in the calculator, and your least squares regression line is your y hat, or your predicted y value, and it's equal to a plus bx. So to look at that in the calculator easily, you go to Stat and Calc, and then you go all the way down to 8, which is the linear regression, and you keep the x list and the y list, L1 and L2, and you calculate for it. And it gives your a value and your b value. So you can just go ahead and plug them in to the equation, and you get y hat is equal to 1,166.9273 minus 0.5868x. So that would be your least squares regression line equation for part A. So for part B, it says, according to the regression line, how much did the farm population decline each year on the average during this period? And what percent of the observed variation in farm population is accounted for by linear change over time? So the first part of the question asks for the decline each year. And basically this just means slope. So to find the slope, well, in this equation, your intercept is your a value and your slope is your b value. So all you have to do is find the b value. So the slope for the decline each year is, so on average, the farm population declined by 0.5868 million people per year. So that one's pretty simple. And then the second part of the question says to find what percent of the observed variation in the farm population is accounted for by the linear change over time. So basically that means what percent of the observed, or the response variable, which happens to be the population, is explained by the different years or the change over time. So that would mean to find your r squared value, or your coefficient of determination, and in the calculator it shows that it's 0.9770, and it shows that right here on the linear regression screen. And so translating that to a percent, it means that 97.7% of the variation in population is explained by the linear change over time. So that is question B. And then for the last question of basic question, or the last part of the basic question, it says to use the regression equation to predict the number of people living on farms in 1990, and is this result reasonable, and why? So using the answer from part A, your linear regression model, we found that y hat is equal to 1,166.9273 minus 0.5868x. So using that, so your x value is going to be the year, so 1990. So you plug in 1990 into that equation, and you find the predicted population at that year to be negative 0.8047 million people. And to answer the rest of the question, is this reasonable? It is not reasonable because you cannot have a negative population, and this question extrapolates the data, which means you're going outside of a range. And the range we were given was from 1935 to 1980, and 1990 is outside of that range. So we can only predict what we've been given, so we cannot really answer this question. We shouldn't have answered this question in the first place. So the next question is the advanced question, and the advanced question gives the data for powerboat registrations in thousands and the number of manatees killed by boats in Florida from 1977 to 1990. So before we do anything, it says to create a scatter plot of the powerboats registered in Florida and the manatees killed by boats. So I went ahead and put those into Stat and Edit, and I put the years there in L1 for organization. So L2 is the powerboat registrations, and then L3 has the manatees killed. So in second stat plot, instead of L1 being the X list, it's L2, and then L3 is the Y list. So then you hit zoom 9, and it graphs the scatter plot. So the first question says to describe the direction of the relationship, and is it positively or negatively associated? So looking at this scatter plot, the direction of it is positively associated because it's going in an upward direction. Letter B says to describe the form of the relationship, and is it linear? So the form is basically the shape of the correlation, so is it in a straight line or curved? And this one is more of in a straight line despite it being a little wavy. So it has a linear form, approximately. And the letter C says to describe the strength of the relationship. So the strength means how closely the points follow a clear form, or how close they are together or how far apart they are. So the strength of this one is moderately strong, or fairly strong. And since this has a strong relationship, that makes it good for making predictions. So the second part of letter C says to, or asks, can the number of manatees killed be predicted accurately from powerboat registrations? And the answer to that question is yes, because it has a strong correlation. And the last question says, if powerboat registrations remained constant at 719,000, about how many manatees would be killed by boats each year? So 719,000 is this very last data point on the graph, or the chart. And so about 47 manatees would be killed each year if it remained at that constant, just because we're already given that point, and it's in a linear fashion, so it's going to continue to follow that. The last question is the AP question, and the AP question talks about windmills generating electricity by transferring its energy from the wind to a turbine. So it just talks about a study that talks about the relationship between wind velocity and the electricity production and amperes. So the first question says to use the computer output that's given to determine the equation of the least squares regression line, and then to identify all the variables used in the equation. So looking at the computer output that's given, well, we know that the least squares regression line is going to follow the form y hat equals a plus bx. So we have to find out what a and b are, because y is going to be the predicted value and x is going to be something we already know. So the a value is a coefficient, and so is the b value. So the constant is all by itself, so the constant coefficient is going to be 0.137, and then since this is a, and the other coefficient that's given is 0.240, and that's the coefficient for wind velocity. Well, wind velocity is going to be changing, so that is going to be our B value. So the finished equation is y hat equals 0.137 plus 0.240x. And then the rest of the question says to identify all the variables used. So the y hat is the predicted electricity production, and the x is the amount of wind velocity. And then for letter B, it says, how much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour more than on a day, or 25 miles per hour than on a day when the wind velocity is 15 miles per hour? So for this one, you want to look at first your slope. So the slope tells you how much the wind velocity is changing the electricity that's being produced each day. And so your slope is 0.240 amperes. So that means that your predicted electricity production is going to increase by that much each day. So after looking at the slope, you have to subtract the 25 miles per hour and the 15 miles per hour to get 10 miles per hour, just because that's the difference of how much wind velocity is within that time interval. So then you're going to multiply that by your slope just to see what that actual difference is. And the difference is 2.40 amperes. So there's a higher electricity production on a day with a wind velocity of 25 miles per hour than a day with a wind velocity of 15 miles per hour. Then the last part of the question says, what proportion of the variation in electricity production is explained by its linear relationship with wind velocity? So the proportion of variation is the percent of response of the response variable, which is the wind velocity in this case, that explains the explanatory variable, which is the electricity production. And that percent is also known as R squared. Well, they give you the R squared, or the coefficient of determination, in the computer output. So the computer output says that R squared is 0.873. So that would be the answer for letter C. And that's the end of Quideo number 2.